Sometimes a little randomness is a good thing. When an ant's out searching for food and it's not picking up any scents, then it will start a random search to try and find food. Bacteria and other microorganisms do the same kind of thing. Random behavior comes into play quite often when an organism is searching for something or has exhausted its repertoire of normal options for dealing with the situation. The random neuron was created to handle the modeling of such behaviors. It uses three random variable equations to set its intrinsic current. These three equations control the amplitude of the current, the length of the burst, and the duration between bursts. A random number is generated between 0 and 100, and it's fed into these equations to find the final values that are used. This allows the user to configure the system using gain functions. Let's begin by creating a project. A copy of this project is located in Program Files, AnimatLab, Tutorials, Neural Networks. Please choose where you want to create this project, and then name it Random Firing Rate Neuron. When you have a new project, add an organism, and then open its behavioral editor. Now add a random neuron to the diagram. You control the behavior of the random neuron by setting the properties of the three random variables that control burst duration, interburst duration, and current amplitude. Let's begin with the burst duration. We'll use the default straight line and set the slope to be 0.013. At a random variable of 100, the burst duration will be 1.3 seconds. Each time the neuron decides to begin bursting, a random variable will be generated and fed into this equation to determine how long the burst will last. Next, set the slope of the interburst duration to be 0.025. For a random variable of 100, the time will be 2.5 seconds. Finally, for the current, we'll use a sigmoidal curve. Adjust the steepness of the curve by setting C to be 0.15. Center the curve by setting A to be 50, and then set the maximum current by setting B to be 20 nanoamps. When the neuron goes into a bursting phase, it will generate a random number and feed this into the sigmoid to determine how much current to apply throughout the burst. Next, create a line chart and add items to view the firing frequency, membrane voltage, and intrinsic current. This generates a random series of bursts with random burst and interburst durations, where all of these are controlled by our random variables. If we run the simulation again, we get a different result. Now let's change the current distribution to be linear and set C to 0.1 nanoamps. Now, for a random variable of 100, a current of 10 nanoamps is generated. Random neurons inject an element of chance into the system. The user can control these systems by setting the properties which control the size of the intrinsic currents and the durations of the burst and interburst times. Random neurons are not typically used very often, but they do provide a very important function.